let's talk a little about Unit 3, Lesson 4. We're going to start to notice some of the characteristics or the attributes of shapes and kind of see if we can see any patterns to them, okay? When we do this, we want to take the two things that we're looking at, the two categories, the angles, the number of angles, and the number of sides. Okay, those are our categories. So I'm going to put those into a chart, and you're going to see some of these in the work you're doing. The charts are already made. You can easily make a chart, though, to help you organize what you know. Okay, this is a category, and this is a category. I'm going to put a line between them to split them. That turned that into a T chart. You see how that made a T? A T chart can help you see two different things and compare them. Okay, so let's talk about the shape right there. That's a square, right? A square has how many angles? Let's find out. 1, 2, 3, 4. It has 4 angles. How many sides does a square have? 1, 2, 3, 4. 4. So I'm noticing that for a square, the angles, the number of angles, matches the number of sides. Let's get a new shape. How about the triangle? Ooh, not a triangle unless it's closed. There we go. Okay. How many angles does a triangle have? Oop, this one doesn't have right angles. They're going to be curved lines to mark my angles. There are 1, 2, 3 angles, and there are 1, 2, 3 sides. Interesting. I'm noticing something, maybe a pattern starting, that the angles and the sides matched for the square and for the triangle. Let's try the rectangle. Okay, angles, 1, 2, 3, 4, none of them. Oops, I marked those angles incorrectly. My apologies. They are right angles. Four right angles. And sides, 1, 2, 3, 4. 4 sides. Okay, I'm feeling like I have a pattern. I'm noticing that the angles, number of angles, is matching the number of sides for any shape that I can think of. Let's go one more. I've got a pentagon here. Pentagon, I'm going to mark the angles. 1, 2, 3, 4, 5. Can you notice if the pentagon has any right angles? 1, 2. Only 2 right angles. The other angles are not right angles. We've got 1, 2, 3, 4, 5 angles. We've got 1, 2, 3, 4, 5 sides. Okay, I'm feeling like my theory, my pattern that I was suspecting is true. The number of angles matches the number of sides. I used my chart to organize the information that I was getting with each shape so I could compare the two things. Okay? Very similarly, we can do this at a little bit deeper level. This time, I'm going to use a chart, and I'm going to look at, I'm going to have a figure or a shape. Okay, let's just use this shape, which we know is a triangle. We know it's got these angles. Look at that triangle. One right angle. The other 2 are not right angles. It's got 3 sides, okay? We're going to go ahead and label our sides. I'm going to start with a T today. This is going to be the vertice T. I need to do U right here so it stays in alphabet order. T, U, V. And I'm labeling the vertices, okay? Now that I have my vertices labeled, I can go and make a chart that looks like this. I'm going to have side as part of my chart. I'm going to have the word estimate as part of my chart. And I'm going to have the word measure as part of my chart. Okay, now I've got 3 categories of information that I want to put into a chart together. I'm going to put lines between them. You'll notice this one is not a T-chart because it's comparing 1, 2, 3 things. T-charts are only made when we're comparing 2 things, okay? So now I'm going to take the information from my shape and put it into my chart. How many sides does it have? Or I'm going to label the sides. So I've got this side, which is the TU side, and I'm going to make an estimate for how long I think, how many centimeters I think that side might be, right? If I'm using centimeters, I would be using my pinky because I know that a centimeter is about the width of my pinky. Remember, I can't use real centimeters when I'm showing you these videos, or these would be way too small for you to see because a centimeter is a tiny standard unit. Okay, so I'm going to kind of mark on the scale of what I'm drawing. This is my estimate, my smart brain guess. My estimate is that this TU side is, and I'm going to count the spaces in between, 1, 2, 3, 4, 5, 6 lengths long, 6 centimeters long. My estimate is 6. Now, measure. Measure means I am really going to get out my ruler and I am really going to measure to see how long that side is, okay? Since I do not have, I can't do this with centimeter because my shape has to be big enough for you to see on the video. I'm just going to use a plain stick. I'm not going to use the number side. If you were to use actually I'm going to use the inch stick. Anyway, when I measure, I'm going to find the 0 point, which is the edge. I'm going to line it up with the end of that line, and I'm going to see if it matches, okay? When I measured this, I actually got 8, right on the button, 8. So I can see that my estimate was a little bit too small. This was the side I'm looking at. This was how long I smart brain guessed it to be based on what I know. And this is how long when I measured it actually was. Okay? I could do this process for each of the sides. So another side that I could do this with is UV. I could write my UV side down. And when I look at my UV side, I'm going to use information I got about my other side to help make my estimate. So I'm comparing two different sides. I'm comparing this side to this side, and I'm asking myself, do they look the same? Does one look a little bigger? Does one look a little smaller? I think it looks a little bit smaller. So my estimate is going to be a smaller number. My estimate is going to be 5. It doesn't look a lot smaller to me. It just looks kind of smaller, okay? So I'm going to do an actual measure, line up my 0 edge, and then write my number. 7 is what I get. Interesting. So my estimate was that it would be 1 less than my first estimate, and on my measure it was 1 less than my first measure. So that's a good indicator, that's a good sign that I'm kind of on the right track with noticing and comparing one side's length to another side's length, okay? If I was going to mark this side VT, again, I would use information that I gained from my other sides to make an estimate, smart brain math number guess, about how long that side would be. I can see with my eyes that this side is shorter than this side and this side. This looks like my longest side. Since I guessed 6 here, and then I estimated 5 here, and my measure proved that that was accurate, I know I need to have a smaller number, an even smaller number for this side. And my estimate is going to be, let's see, that one was 5. I'm going to estimate that one is 4. Okay. I get out my ruler, line up my 0 edge, and it's about 5. So I'm off by 1 again. Actually, I'm off by 2. This time, my estimate was not as accurate as the other times. I guessed that this one was only 1 less than this side, but I was actually wrong in my real measure. It was actually 2 less, because 5 is 2 less than 7. Okay? So a chart like this can help you organize information about your shapes. It helps you figure out things from what you already know, and it helps you use your eyeballs to get a good idea, which estimating with your eyes is something you're going to do when you're hanging curtains, when you're trying to build something at your house, when you're trying to cut wrapping paper to fix your box that you want to put your present in. Estimating really comes in handy, okay?